Today we're insulating this roof from bare rafters to a fully sealed thermal layer and showing you every step. Before any insulation goes in, we need to coat all the rafters with wood preservative. This preservative comes as a concentrate, so first we dilute it with water to the right ratio, then give it a good shake until everything is mixed properly. Even after it's diluted, it still has a strong, sharp smell, so I definitely wouldn't recommend using it in closed spaces without ventilation. Then we brush it into the rafters and all exposed timber that will later be covered with insulation. We're giving it a proper coat so it reaches the gaps and edges, soaks in well, and protects the timber against rot, moisture, and insects. By the gable walls, we don't really have proper fixing points, so we need to make extra braces from 5 by 5 centimeter timber, because later on the battens and the next layers will need something solid to fasten into. We install these braces in line with the existing rafters, so the roof slope continues properly into the sidewall, and later we'll have solid fixing points for the battens and the next layers. It's much easier to do this now, before the insulation goes in. And with that done, we can finally start installing the rock wool insulation. The first row of insulation needs to be trimmed down a bit, because this gap is much narrower than the rest of the spaces between the rafters. We cut the piece about 1 centimeter wider than the gap, so it fits in tightly and holds itself in place without leaving air gaps around the edges. We also need to cut the insulation around the braces we installed, so it sits flush with the face instead of bulging underneath them. This also stops the insulation from being compressed too much, because once it's squashed, it loses some of its thickness and doesn't perform as well. We install the first piece slightly higher, leaving a gap at the bottom because the bottom piece will need to be cut on an angle. That way both pieces can meet properly with no gaps between the insulation. We mark the lower point on one side of the wool, then flip it over and mark the higher point on the other side. After that, we turn the wool sideways and follow both marks while cutting. That gives us a precise angled cut so this piece fits tightly between both pieces without leaving any gaps. The rest of the rafter gaps are wider than the width of our insulation, so every piece needs to be cut lengthways to fit properly. The first piece of each row also needs to be cut on an angle, so it meets flush with the existing wall insulation and doesn't leave a gap between the two layers. Normally, rafter gaps are planned to match the insulation width, so you can fit full pieces straight in, but not on this site. Then we staple a thin string across the rafters to hold the insulation in place and stop the pieces from falling out. As we move higher up the roof, we also need to cut around the collar ties where they connect to the rafters. We install one more piece above the collar tie, but we don't continue all the way to the top of the roof slope. That's because the remaining area around the collar ties will be covered with a thicker layer of insulation between and over them, so there's no need to fill the sloped section any higher. Then we cut the insulation on an angle again, so the flat section by the collar tie meets the roof slope tightly without leaving any gaps. Also, one thing worth mentioning here, when working with rock wool insulation, you should at least wear a proper dust mask or respirator. Even better, use proper PPE. Gloves, eye protection, long sleeves, and a mask. We're not exactly showing the best example here. With all the collar tie gaps filled, we can start installing the second layer on top. For this layer, we're mainly using leftover pieces from the roof slopes since we've got plenty of them. The main thing is making sure every piece sits tight with no gaps between them. Before we can finish the top layer, we need to connect the roof vent to this vent pipe and bring it through the insulation layer. First, we place the pipe where we want it to come through, then mark the size of the hole we need to cut through the insulation. For this section, where the pipe will be hidden inside the insulation layer, we're using a flexible insulated vent pipe. It already has insulation built around it, which makes it much easier to connect to the roof vent. Because it's flexible, we can bend it into position and pass it through the insulation without adding extra connection joints. Then we seal the connection to the roof vent tightly with duct tape, making sure the whole joint is properly sealed. This helps stop air leaks around the connection and keeps the vent pipe closed off, so insulation dust and fibers can't get inside once everything is covered. Over this second layer, we also lay leftover pieces of windproof insulation that we had from the exterior wall insulation. With that, most of the insulation is done. We're just left with the last row by the side wall, where we still need to add bracing. The problem is there isn't a proper fixing point for the ends of that brace, so we make two small 5x5 centimeter spacers and screw them to the existing exterior rafters. Then we seal around those spacers with expanding foam, making sure there are no gaps left between the pieces before the insulation goes in. If you're enjoying this video, there's also a main video on the channel where we go through the full wall, insulation, exterior insulation, and timber cladding on this build. Have a look at that one as well because there's a lot more detail and extra insight over there. The link is in the description. For now, let's focus on finishing this roof. We make sure this bracing lines up with the rafters just like we did on the other side. Then we fill this last gap with leftover pieces from the main roof insulation, since we still have plenty left and it makes sense to use it here. They're perfectly usable pieces, we just need to fiddle with them a bit more to make sure everything sits tight with no gaps between them. And with that, all the main insulation is installed, so we can move on to installing the vapor barrier. First, we roll it out to the full length of the roof, so we can cover the whole section in one continuous run. With a vapor barrier, the key thing is to keep it sealed, with no gaps between the sheets, so it works as one continuous layer. We also make sure to overlap each sheet by at least 10 centimeters, but you should always check your manufacturer's instructions first. And with that done, we move to the sketchiest bit, the middle section, where it drops straight down to the bottom floor. Luckily, the width of the sheet is exactly what we need for this middle section. We can climb through the sidewalls and fix it in place from there. But to be fair, this whole build was awkward to work on, because there was no proper flooring yet, so every step had to be checked before putting full weight down, especially when climbing up the ladder. Basically, there were two things to worry about here: installing everything properly, and finishing this project in one piece. With all the roof sections covered with the vapor barrier, we can move on to sealing all the joints. This part is just as important as installing the vapor barrier itself, because even a small open joint can let warm, moist air get into the insulation. And once that warm air reaches a colder area inside the roof, it can turn into condensation. That moisture can reduce how well the insulation performs, create damp spots, and over time even cause problems for the timber around it. So the vapor barrier only works properly if the joints are sealed properly too. Now it's time to let some light in through the roof windows. We leave enough vapor barrier overhang to seal it properly later when the drywall goes in. These window edges are common weak spots, so they need to stay airtight and protected from moisture. But that's a problem for later. For now, we move on to finishing the air vent installation. First, we find where the vent pipe comes out through the insulation. Then we mark where the fixings need to go so the pipe can be secured properly. Because this section will stay exposed during the build, we're using a rigid pipe here instead of a flexible one. That way, it's less likely to get damaged while work continues around it. This rigid pipe will go straight down to the first floor, so it needs to be fixed solid before the flooring can be installed. Then we seal this pipe together with the previous one using tape. We also seal everything around the pipe and connect it properly to the vapor barrier, so there are no gaps left around. And now, for the last bit, we install these 5x5 centimeter timber battens over the vapor barrier. They create a service gap, giving us space to run cables and fix the next layers properly. They also give us solid fixing points for the ceiling finish, so the next stage has something strong and straight to fasten into. And if you want to see the full story behind this build, check out the main video where we cover the whole wall insulation process together with the timber cladding.